Alright, so we're going to build on the idea of moles now, and we're going to talk about molar masses. And so this is all about the relationship between, you'll never guess, moles and mass. Okay? So these are always going to have units of grams per mole. And so what a molar mass is just how many grams there are for a mole of something. That's it. So if I have 6.022 times 10 to 23 molecules or atoms or whatever, how many grams is that? That's what this is. So remember that we can also convert. We can also convert between moles and grams. And by the way, just like grams can be shortened as a unit to G, moles can be shortened too to MOL. Yes, that's how much of it we can chop. M and MO were already taken, so we go MOL, and it saves us the trouble of writing one or two letters. So we do that. That's just, you'll never guess how lazy chemists are. All right. It's a little wrinkle in this class that I get proven right over and over and over again on that little detail. So here is another piece of evidence in the phone book sized, if you know what a phone book is, phone book sized pile of evidence at this point. All right, so how do we know what a molar mass is? Well, if AMUs, 1 mole of AMUs equals a gram, then if I have 1 mole of something that's, say, I don't know, 4 AMUs, or 1 mole of something that's like 1.01 AMUs, well, guess what? That's 1.01 grams. And that's 4 grams. So we literally just take the number straight off the periodic table for the atomic weight, and we go from AMUs to grams per mole. We just do a unit switch, because we can do that because of how we define the mole. So 1 mole of atoms that are all the same element equals atomic mass in grams. Atomic mass number in grams. So again, to make sure this is clear, what would the molar mass of carbon atoms be? Well, it's 12.01 is the atomic weight. The average carbon atom is 12.01 AMUs. If I have a mole of them, I have 12.01 grams. That's it. It's that straightforward. And so I talked about 1 mole of helium atoms. That's 4.00 grams. And if I look at, say, we'll go with one more element, 1 mole of lithium atoms. Well, gee, I don't have the periodic table memorized, but I do have a copy to look at right here, and that is 6.94 grams. Okay, so guess what I can do with this information? I can set up conversion factors. There's 4.00 grams per mole of helium atoms. There is 6.94 grams per mole of lithium atoms. These are the molar masses. And they're essentially a conversion factor. This is a compound unit, and it lets me switch between grams and moles. That's going to be really important for the rest of the week, but we're going to practice that. And I can go through the whole periodic table and do this. And so what it comes down to, the shortcut is to just take that number and just put grams per mole on the end of it, and you've got it. So, we can ask a question like, what is the mass in grams of 2.5 moles of carbon. Okay. Well, I've got 2.5 moles. I need to go from moles to grams. So what do? Well, there's 12.01 grams for every mole. And then I just calculate it out. It ends up being, I only get 2 sig figs, 30 grams. And I put the dot there so you know that that 0 is significant, but there's nothing after it. A little flashback for you. A little flashback to sig fig land from a couple weeks ago. Alright. And we can go the other way too. So we can go moles to grams. We can also go from grams to moles. You know, just like any other conversion factor. We can go forward or backward. We can go from miles to hours if we know the speed. We can also go from hours to miles using the speed. So, let's do an example of that. So how many moles of copper atoms has a mass of 30.0 grams? Okay. Well, what do we know here? We got 30.0 grams. And let's see, I'm going to need to go moles over grams here. And that'll get me some number of moles. That's where I want to end up. So how do I know what to put in the parentheses here? Well, boom, periodic table, get copper. There's this beautiful light where it'll just completely eradicate. As you can clearly see, copper is. So copper is 63.55 grams per mole, or there's 1 mole for every 63.55 grams. And I just run that calculation out, with a calculator. And I get 0.472 moles. So, we can go from grams to moles as well. So we can go moles to grams, grams to moles. And so, this is the story for, a single element, right? Atoms that are all the same type. What if we're dealing with a compound? What do we do? If it's a ionic compound or a molecule or something like that, what do we do? How do we know what the molar mass is? Well, we just add up the pieces. So the molar masses for compounds these are just the sum of all molar masses for atoms in the compound. The whole is equal to the sum of the parts. So for example, H2O, what do we got here? Well, I've got 2 hydrogens. Hydrogen, one of them by themselves would be 1.01 grams per mole. So I'm going to have 2 of those. And I'm going to have an oxygen, which is, wow, that was amazing. I didn't even try. Just put it right in the spotlight. Alright, so it is 16.00. grams per mole. And I just add this up. So this is the mass of my 2 hydrogens. This is the mass of my 1 oxygen from my formula. I add it up and I get 18.02 grams per mole. How about that? Hot dog. Alright. Now, for a molecular compound, we're going to do a little bit of the vocabulary game here. This is a molar mass, but for a molecular compound, it can also be called a molecular mass. So, it's like, you've got cars and you've got trucks, but they're both automobiles. Well, we'll have a different name for ionic compounds, molar mass, but they're all, anyway. Let's do an ionic compound. I wonder which one we should do. What is an ionic compound that I don't bring it up often enough? What could we? How about NaCl? Yeah, let's look at some table salt here. You guys are gonna be so sick of you're not even gonna salt your food after this class. You're gonna be so sick of salt. All right, so sodium. I've got 1 sodium. 22.99 grams per mole. I've got 1 chlorine. 35.45 grams per mole. For whatever reason, when I do that, by the way, I take the periodic table and I look at it and I point, and then I look up at my computer screen where I'm recording to read the number. I don't know why I do that. That's weird. I guess to make sure I don't have it. I don't want to be doing this. But I just noticed I was doing that. That's weird. Alright, so we add the two together and we get 58.44 grams per mole. Alright, and so for an ionic compound, this can also be called, so it's a molar mass, or we can call it the formula weight. So ionic compounds have formula weights, covalent compounds have molecular masses. These are both molar masses themselves. Just a heads up, because you see these terms get thrown around a lot, including in the homework. So, guess what we can do with our molar masses? Exactly what we did before. We can convert between moles of stuff and grams of stuff. So the molar mass for every compound is different. Compound is going to be different, but we can use it in the same way, right? So just like we did with atoms, we can go grams to moles, we can go moles to grams. And as an example of that, we could ask something like, what is the mass in grams of 3.50 moles of NaCl? Well, you thought I was going to choose water? Come on. Okay. Well, we already have the pieces. We've done the work. Now, if you had this problem and you didn't know the molar mass of NaCl because we didn't just calculate it, that's what you would do. You would just do this process right here. You just add up the pieces, boom, you got the molar mass. We convert moles to grams. So we know we got 3.50 moles. Alright. And there's 58.44 grams per mole. Alright. That comes out to be 205 grams. So same trick we did before, but it's a new substance, so it has its own molar mass. And just like before, we can go moles to grams. We can also go grams to moles. So we could ask something like, how many moles of H2O have a mass of 50.0 grams? What do we do? Well, we've already calculated our molar mass, so that step is taken care of. So I guess I just carry out the conversion now. So it's 18.02 grams per mole, or it's 1 mole for every 18.02 grams. And that comes out to be 2.77 moles. That's it. That's all we have to do. So, same trick as before, but now we have the little added wrinkle of adding up the pieces for compounds. So now you can figure out the molar mass of every element and any compound. You don't have to memorize the elements. You just look them up on the periodic table, and you just use the ones you need to add up with, multiplying by however many there are in the formula to get to the end. All right, so this will be the introduction of molar masses right here. This is going to be a very key idea. Everything we're building towards it's going to be the last video of the lecture. So now you're starting to see, a little bit of chemistry and math, a little bit of numbers and chemical symbols getting mixed together. That's going to be a theme that carries on for quite a while now. And so I've got one more video to make, and then in the last video, this is all going to come back. So I'm not just showing it and then dropping it. This is a very important idea. It's a very important type of conversion to do, because oftentimes we have to do calculations in moles, but we make our experimental measurements in grams. So this is a really important type of calculation to be able to do, where we need to know how many grams to expect at the end. But we'll deal with that in the last video. So we're going to kind of take a new perspective, a mole perspective on chemical equations in the next video. And then in the last, so that'll be the third video, and in the last one we'll do what's called stoichiometry, which will be making this have a comeback. Alright.